Hi everyone, today we're going to be looking at limits. This is a super short little section and I'll just be showing you a theory and a couple of examples for it. So you might remember we talked about limits when we did the asymptotes. Okay, we did them when we were graphing logs and exponentials. We also saw them again when we were doing tangent graphs. So limits are the maximum that we can get. So a way of explaining this is that circle there. I could tell you that the area was 15 square centimetres. Okay, but if I asked you to find that using rectangles, you could start off with a big rectangle and you'd be pretty close to the area. You could put some more rectangles in that are smaller and you'd get closer to the area again. You could see all these little gaps up with tiny, tiny little rectangles, add all the areas of the rectangles together and you would get very, very close to the area of the circle. Okay, so it's getting infinitely closer is the idea that we're looking at here. Infinitely closer, but we're not touching. Okay, and we will never go over 15 centimetres unless you put those rectangles outside the circle. Okay, so it's a limit. And I've done a little notation here just to show you what I mean by that. So it's the limit as x, the area approaches 15. Okay, so that's the concept. In practice, it's very, very simple. So I'm going to show you a function here. This is a cubic function. And I want you to pay attention to this here, because this is the notation that you'll see for the rest of the calculus unit. So find the limit of the function, so f of x, as x approaches 4. Okay, so as x approaches 4. So if we start over here, we're getting closer and closer to x equaling 4. Actually, it might make a bit more sense if I put it here. We're getting closer and closer to x equaling 4. And this is from both ways. Okay, so we get closer and closer and closer and closer. Okay, we're not going to hit 4, but we're moving towards 4. And what they want to know is what is f of x, or what is y, as x gets closer and closer to 4. Okay, very simple, it's 14. Okay, and we would write it as the limit of f of x as x approaches 4 is 14. Okay, so it sounds very complicated, but I promise you it's not. It's just as you get closer to that x value, what's the y value going to be? Okay, you might think, okay, that's all right on the graph. How do we do it with a written one like this? Okay, and we could draw a graph if we wanted to. 2x plus 5, we're going to start at the 5 there. Okay, we could do it like that. And we could think about as x approaches 2, where is our graph going to be? Obviously, it's going to be a bit more than 5. Okay, but the easiest way to do it is just to sub in what the value of x is going to be. So the limit of 2x plus 5 as x approaches 2, we could rewrite as, okay, so I've subbed in, I might do that in a different colour. Okay, we've subbed in where we want to find x. So we're saying x is 2, we're getting closer and closer to 2. If we could just find out what y is when x is 2, then we could find our limit. So 2 times 2 is 4 plus 5. So the limit of 2x plus 5 as x approaches 2 is 9. Okay, so they're saying that they want the value as we get closer and closer to that x value. We can find out the y value at that point, and that will tell us what the function is approaching. Okay, so it sounds a bit cooler than it is. It's pretty much subbing in and evaluating. And later on, if you go on to do methods 4, you will see hybrid, discontinuous, rational functions that make it a lot more difficult. But in this course, this is about as hard as it gets without fractions. So we're going to do one with fractions because everyone seems to hate them. And we're just going to sub this one in as well. So the reason I've picked this one is something I keep seeing people doing is going x on top x on bottom, and cancelling those out. So this is the same as x plus 3. You cannot cancel down one term and one term. If there's two terms on the top, you've got to take an x out of both of them. You can't just take it out of one of them. Okay, so how we would approach this one, limit as x approaches 2. Wherever we saw an x, we'd put a 2. And then we'd simplify. So 2 squared is 4, plus 3 is 7 over 2. Or 3.5. Okay, so just be careful with your simplifying when you do these. There's quite a few questions in your exercise sheets that ask you to simplify. Oh, if I can find them, so down here, just be really careful with the fractions. Okay, so that's it. Limits do get harder, but fortunately for you, not in this course.